Hello students, myself Dr. Rachna Patak, Assistant Professor in Faculty of Engineering and Technology, University of Lucknow. The topic of today's lecture is application of double integration and triple integrations for finding areas and values. Firstly, know what is double integrations. We know that this is an integration sign, double integration, that is a to b, and this is y1 y2 dx dy, or we can write this integration a to b x1 x2 dx dy. Okay. There are two integrations where y1 y2 is a limit of y in the function of x, and x1 x2 is a limit of for x for in the function of y. A b is a constant value. For double integrations, we used in the Cartesian form or the polar form for finding the area of the enclosed curve. We have two methods. First method is draw a strip parallel to x axis, and second is draw a strip parallel to y axis. So, firstly we go to the draw the strip parallel to the y axis. So, for this let the curves AB and CD be y1 is equal to f1x, this is a AB, is y1 is equal to f1x, and CD y2 is equal to f2x, AD is equal to x equal to A, B to C is equal to x to B. This is the enclosed area is ABCD. We want to find the area of this enclosed curve. For finding this, we draw the strip parallel to the y axis. This is a strip parallel to the y axis, and we find the limit of y axis in the form of function of x. So, here we get you can see here that is a strip start here and goes to here. The limits, the lower limit is y1, upper limit is y2, and the x goes to a to b. So, formula can be written as integrations a to b y1 y2 dx dy. If in the previous example, if we draw the strip parallel to the x axis, if draw the strip parallel to the x axis, the limit is corresponding to change. That means, we write the limit of x in the function of y, that is f1 y, and next to is a f2 y, and the constant limit for y axis, and we can written as this. And we will solve some example for the step parallel to the y axis. This is the example. First, find the area bounded by the lines. Here we have three lines, y is equal to x plus 2, y is equal to minus x plus 2, x is equal to 5. What is the first step? The first step for solving like these equations, firstly we want the interactions term between the lines. Here is the three lines, y is equal to x plus 2, next is y is equal to minus x plus 2, and x is equal to 5. What is the interaction point? Adding both equation we get 2y is equal to is 4, y is equal to 2, and put y is equal to in the both equations we get the values of x coordinates. If y is put 2 here, y is 2 here, x is 0. So, the coordinate is 0 comma 2. Find the next coordinate is put x is equal to 5 in the first equation we get 5 comma 7, and put 5 in the second equation we get 5 comma minus 3. There is a 3 coordinates which intersection points between these lines. After this we draw the figure. Figure is like this, y is equal to x plus 2. We know that what is the standard equation of a straight line? Y is equal to mx plus c. Here is the line is y is equal to x plus 2, and next is y is equal to minus x plus 2. Here m represent the slope of the line and the x coefficient is 1, that is the positive slope and is a negative slope. So, direction is also a change. The line equation is y is equal to x plus 2, another is y is equal to minus x plus 2, and next equation is x equal to 5, that means it is parallel to the y axis. This is the shaded area. We want to the area of this enclosed triangle. So, for this these are interaction point, that is a 0 to 5 minus 3 and 5 comma 7. For this we draw a strip parallel to the y axis. This is a strip parallel to the y axis. So, first find the limits corresponding to y and x. So, we first write the integration. What is the limit for y? Here we can say that we write the limit y in the function of x. So, here y is minus, it goes to here lower to upper, minus x plus 2, another is x plus 2, and x axis goes to 0 to 5. This is the required integration. In solving this integration, we find the area of required closed curve. So, we have integrations, we can say that integration dx dy and put the limits 0 to 5 minus x plus 2 and x plus 2. And note, always remember that if the limit in the form of x, we firstly integrate in respect to y. If the limit in the function of y, we integrate firstly x. So, here the limit in the function of x, so we integrate this integration with respect to y. There is a 1 which integrate is here y and put a value minus x plus 2, we goes to x plus 2 minus x plus 2 and solve this, we get 0 to 5 2x x dx, and integrate this integration with respect to x, we have get the x square 0 to 5 is 25 the square limit. Unit, this is required result. Okay. And next example also find the area of the given curve. So, here evaluate the area enclosed between the parabola and the straight line. What is here? First step again, y is equal to x square, y is equal to x, this is a parabola equation, this is a straight line. Firstly find out what is the interaction term between. So, put here x, y is equal to x square, that means x square minus x is equal to 0, x minus 1 is equal to 0, probability is s equal to 0 or 1. The corresponding value is, because we know that y is equal to x, the points of interaction is 0 comma 0 and 1 comma 1, and draw the figure. Here this is a parabola, y is equal to x square, this is a parabola, and the straight line cut this parabola is 0 comma 0 and 1 comma 1. We draw the strip parallel to the y axis. We draw the strip parallel to the y axis. So, first find the limit corresponding to y. Here we can see here that the last point is touch the curve. So, the limit corresponding to y is x square to x, okay, and the limit of x corresponding is 0 to 1 and dy dx. Okay. If we want to draw the strip parallel to the x axis, we can also solve the equation. We will solve after this. So, firstly goes with this, with the integration 0 to 1 x square to x limits, and integrate with respect to, yes, limit in function of x. So, integrate with respect to y, we get y is, because one is integration is y x square to x, and put the limits x minus x square dx. Here is only x function of x. So, integrate with this integration with respect to x, we get x square by 2 minus x cube by 3, which is 1 by 6. Now, we again solve this curve when we draw the strip parallel to the x axis. If we draw the strip parallel to the x axis, this is a strip is parallel to the x axis. There is any changes? First, we write the limits corresponding to x in the function of y. So, here we can say that where is a y is equal to x and y is equal to x square, this is start to left to right. So, here we can, the point is x is to y, that is y goes to x for positive value, that is under root y, that is x goes to y to under root y, and y goes to 0 to 1 is obvious, and dx dy. We can solve this integration, what, 0 to 1 y to under root y dx dy. Here is the limit in the function of y. So, integrate this integration with respect to x. What is this? X under root y minus y. After the putting the values, this is y. I integrate this integration with respect to y. What is the value of y ki power 1 by 2? We know that s ki power n integration is s ki power n plus 1 upon n plus 1. What is integration here? Y power 3 by 2 is 3 by 2 minus y square by 2, and integration limits is 0 to 1. Solving these equations, we get 2 by 3 and y is 3 by 2 in minus y square by 2, and put the limits 1 to 0, we get 1 by 6. So, we can see here, if we draw the strip parallel to x axis or parallel to the y axis, there is no change the final result. We get same result if we draw the parallel to the x axis, parallel to the y axis. So, there is a two method. According to question, we can use what step we use, if parallel to the y axis, if the limit finding according to the y is easy, we use parallel to the y axis. If the limit corresponding x axis is easy, we draw the strip parallel to the x axis. So, we goes to the next question. Before this we and solve the question in the Cartesian coordinates. In this example, we find the area in the polar coordinate. This form is not different others. We put only, we know that s equal to r cos theta, y is equal to r sin theta. Everyone know that. What is x square plus y square is equal to r square. Use the Jacobian matrix, we can see that dx dy is equal to r dr d theta. Okay. So, put here where integration is dx dy, we put here r dr d theta. In the place of dx, we put r dr d theta dr, and put the limits of corresponding to r and theta, and solving this integration we get the required result. So, goes with example, find the area of the one of the loops is s ki power 4 plus y 4 plus equal to 2a square xy by converting into polar coordinates. So, firstly we have, what is the equation? This is the equation, x ki power 4 plus y 4 is equal to 2a square xy. Put s equal to r cos theta, y is equal to r sin theta, we get what? R power 4 cos theta plus r power 4 sin theta is 2 square r square sin theta cos theta. Solving this, we get r is a function of theta, r is equal to 2a square sin theta cos theta sin power theta plus cos 4 theta. And now, we find the limit corresponding to theta and r. Here we can say that it put r is equal to 0, we have two possibilities, 2a square sin theta cos theta is equal to 0, because this is equal to 0 and multiply. So, we have only choices here, 2a square sin theta cos theta is equal to 0, a is a constant value, it will never be 0. So, cos sin theta may be 0 or cos theta is 0. If sin theta is equal to 0, which implies theta is equal to 0. If cos theta is equal to 0, which implies theta is equal to pi by 2. The range for the theta limit is 0 to pi by 2. If for the limits for r, what is the limit for r? We can see that from the diagram, this is the radical strip and the r goes to the positive coordinates. So, the value of r is 0 to under root 2a square sin theta cos theta upon sin 4 theta plus cos 4 theta, and put the limits in the integrations, where integration is 0 to pi by 2, 0 to under root a square sin theta cos theta upon sin 4 theta cos 4 theta r dr theta. We always remember the limits in the form of theta. So, integrate this integration with respect to r. What is r here? Integrate with r square by 2 and put the limit, we get this. This integration 1 by 2 0 pi by 2 2a square sin theta cos theta upon sin 4 theta plus cos 4 theta d. We go to the further calculation, we simplify this integration. We have some properties of integration. So, solve this using this properties and solve this integration. We common to the both side, that is we can solve it. 1 by 2 is 0 by pi by 2 2a square sin theta cos theta and common to out cos 4 theta, which may tan 4 theta plus 1 d theta, and solving this we get 1 by 2 0 to pi by 2 is 2a square 1 cos theta with sin theta is tan theta, and when remaining sin square is sec square theta d theta upon tan 4 theta plus 1. We let tan square theta is t, that means integrate differentiate this 2 tan theta sec square theta d theta dt. Put this value at the place of this. This is given to a square by 2 and this is dt, and t power 10 power 4 is t square plus 1, that is the integration here. And also remember, if we put the value as the another variables, we also change the limits. Here limit is 0 to pi by 2. How to change? There is a lower limit is 0. Put here, we know that tan theta square is equal to t, and put t theta is equal to 0. Tan 0 square is equal to t. We know that tan 0 is 0, that is t is 0. Lower limit is 0. What is upper limit pi by 2? We put theta as pi by 2. Everyone know that tan pi by 2 is infinity, so that goes to t infinity. So, lower limit is 0, upper limit we will just infinity, a square by 2 0 to infinity dt upon t square plus 1. Integrate this integration, we have tan inverse t, 0 to infinity, put the values a square tan infinity minus tan 0, tan infinity goes to pi by 2, this is pi a square by 4, which is the required solution of this curve. We also will change in the, we can solve this equation in the Cartesian form also. And next is volume solid by the double integration. We solved example on the base in the last example, what is the volume and what is the solved by double integration, where is the formula is v is equal to double integration z dx dy. For solving this integration, we always remember z, there is a no integration with respect to z. So, always put the z in the form of x and y. So, we will solve one example on this topic in the last example. So, we again go the find the area lying between the parabola y is equal to 4x minus x square and the line y is equal to x. Okay. Here is one is a parabola, other is a straight line. We again start first step, what is? We finding the intersections points. What is the intersection points? We put y is equal to x is, we put x is equal to x, we get 0, 3, values of x corresponding to 0, 3 and y is equal to x. So, the intersection points is 0, 0 and 3, 3. What is the direction of parabola? Is the y is equal to 4x minus x square. This is the parabola. Parabola is y is equal to 4x minus x square, and a straight line cut this parabola at 0, 0 and 3, 3. We have two methods here. First is parallel to the y axis and second is parallel to the x axis. Okay. We draw the strip parallel to the y axis. We first find the limit corresponding to y. If we draw the strip parallel to the x axis, we find the limit corresponding to x in the function of y. Always remember that we draw the strip parallel to y, we always find the limits in the function of x. If we draw the strip parallel to the x axis, we always find the limit for x in the function of y. So, we firstly solve this equation by draw the strip parallel to the y axis. We find the limits in the function of x. So, y is equal to x and y is equal to 4x minus x square. So, limit for y is x to 4x minus x square, and what is the limit for x? We can see that interaction function goes to 0 to 3, that is 0 to 3 is limit, and this is dy dx. If we draw the strip parallel to the x axis, there is the only purpose in solving draw the strip parallel to the x axis and y axis is simplify the integrations. If this is simplify, if the draw the strip parallel to the y axis is easy, then parallel to the x axis we use that. If draw the strip parallel to x axis easy, then parallel to the y axis use them. There is no restriction, you use the strip parallel to the y axis or parallel to the x axis. You have choice, you draw the strip parallel to the y axis also and draw the strip parallel to the x axis also. So, we can go through the parallel to the y axis, we have this limits. If draw the strip parallel to the x axis, what is the limit? We can find this limit in the function of y, x in the function of y, There is, we can see that the value of x in the form as y is not easy here. So, when the function of x is not easy in the form of y, we use another method and draw the strip parallel to the y axis. So, here y parallel to the y axis is easy than parallel to the x axis. So, we prefer here draw the strip parallel to the y axis and find the limits parallel to the y axis and parallel to the x axis and solve these integrations. We have integrations limits as 0 to 3, 0x to 4x minus x square, dy dx. Always remember this is a limit in the function of x. So, integrate this integration with respect to y. This is 4x minus x square minus x dx. Integrate this integration is we get respect to x and solve this is for 4.5. Okay. They parallel, if we draw the strip parallel to x axis, it becomes difficult, but the answer is always same. We go to the next question. Determine the area of the region bounded by the curves. Here curves is xy is equal to 2, 4y is equal to y square and x square y is equal to 4. This is the lines and the integration is we draw the strip. There is a curve y x square to 2 by y and 4y is equal to x square and y is equal to 4 is parallel to the x axis. So, we can see here if we draw the strip parallel to the y axis is not easy, find the limits of y in the function of x. So, we draw the strip parallel to the x axis. We draw the strip parallel to x axis and find the limits of x in the form of y is x 2 by y and x square, that means under root 4y, that is positive, take the positive value also, x equal to 2 under root y. The limits is x equal to 2 by y and 2 under root y, and put the value of y axis is 1 to 4, and with the limits of in the function of y, we integrate this integration with respect to x, because there are limits in y, we integrate this integration with respect to x. We have 2 under root y minus 2y, put the limit and integrate this integration with respect to y, we get the required result. And let us go to the last example. Find the volume bounded by the cylinder x square plus y square is equal to 4 and the planes y plus z is equal to 4 and z is equal to 0. This is the question based how to find volume by double integration. From the figure, there is a figure so some difficult. From this figure, it is clear that what is the value. We always see what is the formula for value, this is formula, and put the first three value z in the function of x and y. Here we see that z is a function of 4 minus y. The z's value is 4 minus y is to be integrated over the circle x square plus y square to 4 in the xy plane to cover the shaded half of the circle. X varies. What we get the limits for x before goes to the this. What is x square plus y square is equal to 4, that means x square is equal to 4 minus y square, x is equal to 4 minus y square. We take the positive coordinate, that is s goes to 0 to under root 4 y square, the limit varies for x axis, while y goes to minus 2 to 2. We can put here, if we want a limit for the y axis, put x is equal to 0. If x is equal to 0, y is equal to 4 and y goes to 4 under root which is plus minus 2. So, y varies to minus to 2 and put all limits in the integrations. We have 2 0 to minus 2 2 under root 4 minus y square z dx dy, and put a limit 4 minus y dx dy and integrate this respect to x. The limit is y. So, we have this 2 minus minus 2 4 minus y under root 4 minus y dy. We can see that we always know that if integration has same limits with different size, if function is even, then integration is values 2 times 0 to a fx dx. Otherwise, if function is odd, the value of integration is 0. So, we separate this 4 times under root 4 minus y square and separate this part is odd function. So, integration is goes to 0 and this is 4 times 8 minus 2 under root 4 minus y square 4 to 8 dy, integrate this integration is 16 0 to under root 4 minus y square dy. We integrate this integration with respect to y. We know that the formula y under root 4 minus y square by 2 plus 4 by 2 sin inverse y by 2 and put the limit 0 to 2. That is the required solution 16 by 16 pi. So, in the lecture we will study how to find the area and value with the help of double integration. Always remember, if the limit in the form of y function, we firstly integrate with respect to x. If the limits in the function of x axis x, we can integrate limit in with respect to y.